Hello everyone. In the last video, we have seen the Laplace transformation of a function when it is multiplied by t to the power n for a positive integer n. Okay. In this video, we will find the Laplace transformation of a function when it is divided by t. Okay. So let us write that title: Laplace transformation of f of t upon t. So theorem: if Laplace transformation of function f of t exists and it is f of s, then Laplace transform of f of t upon t is equals to integration s to infinity f of s ds. Okay, remember this. We are going to prove this now. Proof: let Laplace transformation of f of t exist and it is f of s, then by definition of Laplace transform, then by definition of Laplace transform, we have f of s equals to integration 0 to infinity e to the power minus st f of t dt. Give it number 1. See, we have to prove Laplace transformation of ft by t is equals to integration s to infinity f of s ds. So, assuming that this function f of s is integrable between the limits s and infinity, let us assume that f of s is integrable between s to infinity. So if it is integrable, then we integrate it. So integrate 1 with respect to s between the limits s and infinity. We get integration s infinity f of s ds equals to integration s to infinity integration 0 to infinity e to the power minus st f of t dt ds. Okay, so now you have to solve this double integration, and you have already seen how double integrations are evaluated or treated in the last semester. Okay, so in this case we will we're gonna change the order of integration. Okay, so we take this integration here, integration from 0 to infinity, here integration from s to infinity e to the power minus st ft d, sorry, it is dt here and ds is here. Okay, this is by changing the order of integration, changing the order of integration. Okay, so integrate it with respect to s. What is it? Integration of e to the power minus st with respect to s is e to the power minus st upon minus t, limits s to infinity ft dt, integration 0 to infinity, apply this limit to e to the power minus t st, you will get e to the power minus infinity minus e to the power minus st upon minus t f of t dt. Okay, or this can be written as integration 0 to infinity e to the power minus infinity tends to 0. This minus 1 and this minus 1 will be plus 1, and the things remains here are e to the power minus st into f of t upon t dt. And by definition, this is the Laplace transform of f of t by t is equals to Laplace transform of f of t by t by definition of Laplace transform. Okay, and what we have in this side, it is integration s to infinity f of s ds. Okay, so this is the Laplace transform of a function divided by t. And what is it? It is the integration of f of s from s to infinity. And what f of s is? It is the Laplace transform of this function f of t. Okay, so let us go to the examples now. Examples: find the Laplace transformations. Find the Laplace transforms of the following functions. Number 1, e to the power minus at minus e to the power minus bt upon t. Number 2, 1 minus cos t upon t square. And number 3, sin t upon t into e to the power 2t. Okay, so let us start with number 1, solution. We have the Laplace transform of a function ft divided by t as integration s to infinity fs ds. Okay, where capital F of s is nothing but the Laplace transformation of function f of t. So number 1, let us denote e to the power minus at minus e to the power minus bt by f of t. Then Laplace transform of f of t will be Laplace transformation of e to the power minus at minus e to the power minus bt, which then by linearity property Laplace transform of e to the power minus at minus Laplace transform of e to the power minus bt, which equals to 1 upon s plus a minus 1 upon s plus b. Now we have to find Laplace transformation of e to the power minus at minus e to the power minus bt upon t, and whose Laplace transform will be integration from 0 to infinity Laplace transformation of this part f of t, which is 1 upon s plus a minus 1 upon s plus b. Okay, instead of writing directly, you can write here under the integral sign Laplace transformation of e to the power minus at minus e to the power minus bt, and then you write this step. Okay, this is your choice. So integrating this, what will be the integration 1 upon s plus a? It is log of s plus a minus log of s plus b, limits are s to infinity. This is nothing but log of s plus a upon s plus b, limits s to infinity. After applying the limit, what will we get? Uh, you take s common from numerator and the denominator also, then s will be cancelled, and what remains then here? Log of 1 plus a upon s upon 1 plus b upon s. Then apply the upper limit. You will get 0, 0 in the second term in both numerator and denominator, and 1 here in the numerator and denominator. So this will be at upper limit 1. So log of 1 minus at the lower limit, this will be log of s plus a upon s plus b, and log of 1 we know is equals to 0, and we get here log of s plus b upon s plus a, taking minus 1 into power of s plus a upon s plus b by property of logarithm. Okay, so this was the Laplace transformation of e to the power minus at minus e to the power minus bt upon t. Okay, what is the next example? 1 minus cos t upon t square. Example number 2, let f of t is equals to 1 minus cos t upon t square. See, here in this example we have t square in the denominator, okay, but we have this Laplace transform for a function divided by t only. Okay, so you take 1t from the denominator into the numerator, and take 1 minus cos t upon t as your function f of t. Okay, so that is what we have taken here. Sorry, it is not 2, it is 1. So let f of t is equals to 1 minus cos t upon t. Then its Laplace transform is, then Laplace transformation of f of t is equals to integration s to infinity Laplace transform of 1 minus cos t ds. Okay, uh, then by the linearity property, this will be Laplace transformation of 1 minus Laplace transformation of cos t ds, which equals to integration s to infinity Laplace transformation of 1 is 1 by s minus s upon s square plus 1 Laplace transformation of cos t ds. Now do the integration. This will be log of s minus 1 by 2 log of s square plus 1. I hope you know the integration, how it is equals to 1 by 2 log of s square plus 1. You just adjust 2 in the numerator and denominator, and then use the substitution method. You will get log of s square plus 1 upon 2. Okay, so this is the integration with the limits s to infinity. And now you take 1 by 2 common from both the terms. You will get 1 by 2 here, and here will be log of s square minus log of s square plus 1, limits are s to infinity. So this is log of s square upon s square plus 1 with the limits s to infinity. Now you can apply the limits. Here again take s square common from the denominator, then that common s square will get cancelled with this s square, so this will be log of 1 upon 1 plus 1 upon s square, and at s is equals to infinity this will be log of 1. So this is log of 1 at s is equals to infinity minus at s is equals to s, this is log of s square upon s square plus 1, which equals to log of 1 is 0. So this is 1 by 2 log of s square plus 1 upon s, because this minus 1 is taken into the numerator into the power of s square upon s square plus 1. So this was the Laplace transformation of 1 minus cos t upon t, but you have to find Laplace transformation of 1 minus cos t upon t square. Now Laplace transformation of 1 minus cos t upon t square is equals to Laplace transformation of 1 minus cos t upon t upon t, which equals to integration s to infinity. See, now we have 1 minus cos t upon t as f of t, okay, whose Laplace transformation we have evaluated as 1 by 2 log of s square plus 1 upon s, and that comes under this integral sign. So write that transformation here, 1 by 2 log of s square plus 1 upon s square. I have missed s square here, okay. ds. So next step, there is an integration, take 1 by 2 out of integral sign, so you have to integrate log of s square plus 1 upon s square. You take a help of integration by parts while evaluating this integration. So integration s to infinity 1 into log of s square plus 1 upon s square ds, okay. You keep this as a first function and this as a second function while applying integration by parts. So this will be first into integration of second, so log of s square plus 1 upon s square, first into integration of second is s limits s to infinity minus integration of derivative of first function, that is derivative of log of s square plus 1 upon s square, which will be 1 upon s square plus 1 upon s square, that is s square upon s square plus 1, and derivative of s square plus 1 upon s square, which is nothing but by quotient rule s square into 2s minus s square into derivative of s square plus 1, that is 2s. Sorry, I have mistaken somewhere. Let me see again. We have to derivate s square plus 1 upon s square here in multiplication with this, okay. So applying quotient rule, we get s square into derivative of s square plus 1, which is twice s, minus s square plus 1 into derivative of s square, that is 2s. upon s power 4. Okay, so integration of derivative of first function is done, and integration of second function, that is s ds. Okay, so the next step will be, this is 1 by 2 s into log of s square plus 1, or instead of writing s square plus 1 upon s square, you just separate denominator here. You will get 1 plus 1 by s square. Limits are s to infinity, minus, here what will you get? See, this s square, this s cube, this s cube, and s cube from here will get cancelled. Okay, next, here we have s square into 2s, that is 2s cube minus this 2s into s square will be again 2s cube. So 2s cube minus 2s cube will get cancelled, and one term is here minus 2s. Okay, so minus 2s I am writing in rough here, minus 2s we are getting in the numerator, upon here after cancellation we are having only one s. Okay, into 1 upon s square plus 1. So this s and this s again get cancelled, and minus 2 upon s square plus 1 remains. Okay, so we take minus 2 out of the integration sign, so this will be plus 2 integration s to infinity 1 upon s square plus 1 ds. Hope these calculations are uh, clear to you. Okay, so the next before going to the next step, let me uh, show you the logarithmic series. Recall, because we are going to use that here. Log of 1 plus s is s minus s square upon 2 plus s cube upon 3 minus so on. I'm not going to write the next terms. This is an infinite series. Okay, so we are going to use this expansion of log 1 plus s as here log of 1 plus 1 by s square. Okay, so 1 by 2 here, s into log of 1 plus 1 by s square with this series will become s, that means 1 upon s square. We have s here, and here in place of s we have 1 upon s square, minus s square, that is 1 upon s to the power 4 into 2, and so on. So the power in the denominator getting increased term by term. Okay, and we have to apply limits as s to infinity plus, what about this integration? Integration of 1 s square plus 1, this is tan inverse s. Okay, 2 is here in multiplication. Limits are s to infinity. So you take s inside the bracket. The first term will be 1 by s minus 1 upon 2 s cube, and so on. Okay, and after applying the upper limit, that is s is equals to infinity, you will get 1 upon infinity minus 1 upon 2 into infinity, and so on. So This will be 0 because infinity is there in the denominator. This fraction is also 0. So every term in the bracket at upper limit will become 0. Okay. So we are not going to write that. So 1 by 2, that 0 at upper limit minus at lower limit, that is x is equals to s. This will be this will be mm, s into log of 1 plus 1 by s square. I'm not writing this whole expansion. Okay. uh, Plus 2, apply the upper limit here, tan inverse infinity minus tan inverse s, which then equals to 1 by 2, this uh, minus s log of, simplify this, s square plus 1 upon s square plus this 1 by 2 into 1 into 2 will be 1, and tan inverse infinity is pi by 2. Okay, minus tan inverse s. Okay, and now you take this minus 1 into the power of s square plus 1 upon s square. You will get s upon 2 log of s square upon s square plus 1 plus pi by 2 minus tan inverse s. Okay, so this is your final answer. That is the Laplace transform of 1 minus cos t upon t square. This. Okay, so the next example you can try. And what was that? This. Find the Laplace transformation of sin t upon t into e to the power minus t. What you do here? You bring this e to the power 2t into the numerator, and treat e to the power minus 2t into sin t as your f of t, and then find its Laplace transform. Okay, so this is your hint. You do this number 3 as your assignment. The remaining part of this unit we will see in the next video. Thank you.